75-25. Main one was 75% argon. Next one was 25% CO2. Okay, we have to get into material or filler metal selection. So if you're following along the book, we're on page 711, electrode wire, electrode filler wire. Okay, so we're going to start out under the solid electrode wire article. Used for gas metal arc welding, generally smaller in diameter. The most typical one you'll see in industrial applications is 035. Small houses and shops, you might get down to an 030 or 025 depending on what you're doing. Okay. You can see thicker materials, you can get all the way up to 1/8 of an inch. So we talk about the cross-sectional area. So again, the formula for finding your area is pi r squared. We use the pi function on our calculator. Our general one is 3.1416. R is the radius. So we have we have a 10 diameter. The radius is 5. So 5 times 5 is 25 times 3.146. That's how we would find the area. Okay. Move on. Feel free to help yourself look through this. I want to get to so this is kind of an important one here sometimes. Even though flux core wires are generally considered low hydrogen, they can absorb significant moisture. If you see on the top, a seam is formed along the side of the wire. From time to time, this is what happens if you get, we call them worm tracks. Okay? It's what happens if you get moisture that's coming to the surface and can be within that weld from time to time. Okay? We have moisture in it. Moisture is naturally H2O is water, right? So we have hydrogen, 2 parts hydrogen, 1 part oxygen for water. So naturally, if we have moisture, we're going to have hydrogen cracking, quite possibly porosity as well. Okay, we're getting pretty long in this chapter, so I want to jump up here. Feel free to look through the rest. Your book, you can look through page 7115. See if it, let me see something here. Okay, we'll get to it in a second. Flux core, let's talk about gas metal arc welding solid electrodes. So the electrode designation is very similar to shielded metal arc welding. The E is for the electrode. R is for, it's a filler rod, so technically you could use this to TIG weld with as well, depending on the other characteristics. But it is a filler rod, filler metal. 70 is the minimum tensile strength, same thing, 1,000-pound increments. Pounds per square inch increments, sorry. So 70, 70,000 psi. The S indicates it's a solid wire. So GMAW, solid wire electrode, 70S dash indicates the chemical composition, operating characteristics. So one of the projects that I want you to do in here, it's going to be 10 points extra credit. for my students especially, is I want you to figure out, I want you to take note of the differences between 70S, 1, 2, 3, 4, 5, and 6. Give me an explanation of the differences between the X component, the chemical composition and operating characteristics, right here. And then here's the optional supplemental hydrogen designator, whether it's a low hydrogen or so forth as well. So if you want to find show you in the book, I'll point you to the right direction. We are on page 716. Starts on page 715. The first classification, right-hand column, towards the bottom. Second paragraph from the bottom. So the first classification in each of the three types of the electrodes contains minimum amounts of the oxidizers, manganese, and silicon. Next paragraph down, it says the ER70S-2 classification covers a grade of solid wire with considerable amounts of deoxidizers. Next page, 716, bottom left, tells you 70S-3 are very similar to those in 2, except that greater amounts of deoxidizer, manganese, and silicon are included. Wow, okay. So, a little bit of difference. You can keep reading through, find the 4, 5, 6, so forth. Okay. I'm going to move on. This is metal cord. So we want to talk about the metal cord wires. You can find it in the book here, I'm sorry. Starts on page 712. Metal core electrode wires, composite tubular filler metal electrode consisting of a metal sheath and a core of various powdered materials, producing no more than silicon islands on the face of a weld bead. Again, you don't see a lot of cord electrodes. In GMAW, usually you're going to see more of them in the flux core. However, the layout is very similar, except for you notice there's not an R here. It cannot be used as a filler metal externally. So, electrode, 70,000 psi. This means that it's a cord wire, not tubular, but cord. So C indicates the CO2 and M indicates that it needs to have 75 to 80% argon balance, CO2. So whether it's a C or an M, depends, will tell us that factor there. Flux core, tubular flux cord electrode. Now here's the one that's going to throw most people for a loop. FCAW, you have an electrode, and right here it's going to say 70. Now most of us are going to think that's 70,000 psi because everything up to this point means the same thing. However, it's not true. Only the first number designates your tensile strength in flux core. So the 7 means 70,000 psi. The 0 now indicates the position. So 70 means flat and horizontal, 1 means all positions. So it's either going to be 70 or 71. A lot of times you'll see most people are going to run a 71. Okay? The T now is a tubular, so it's got a flux cord inside, indicates usability of the electrode, the X. Trying to think of an example. It's usually like a 71 TM, so forth. I'll find a better example and maybe plug it into the course content as well. You can always research it on your own. Again, an M indicates 75 to 80% argon balance, CO2. If no M is indicated, CO2 can be used or the electrode is self-shielding. Okay? Indicates increased property values on the J. So here's the main portion that I really want to show you about the flux core. I'm going to bring the camera over here so that I can do it this way.